This presentation is called Confidence Interval for a Mean, Sigma Unknown. Previously, I created a video called Confidence Interval for a Mean, Sigma Known. Well, this is the follow-up where we don't know sigma. So here's our introduction. And the first thing it says is to look at page 5 of my outline. So we're going to do that. And here's the middle part of page 5 of my outline. You'll see this 7 over here. That means it's dealing with chapter 7, which is confidence intervals. We're working on a confidence interval for a mean, and you see it says right there Z or T. Well, that's what this sigma business is all about. If we come over here to the right, it tells us that on the calculator we're going to be using stat test Z interval or stat test T interval. We are going to use the Z interval if sigma is known. We're going to use T if sigma is unknown. So in this particular video, we're talking about situations where sigma is unknown. So we're going to be using stat test T interval. And over here, you see the relevant formulas to this process. And then mainly, we're focusing here on the formula for the margin of error. And here you see sigma unknown. So when we get to that point, we're going to be looking at this formula for how to calculate the margin of error when sigma is unknown. So we are back to the main presentation. And this assumes that you have already watched the presentation called Confidence Intervals Introduction. And hopefully you've also seen the videos for confidence intervals for proportion and for mean where sigma is known. Remember, when you construct a confidence interval, you are using information from a sample to estimate something about the population that the sample came from. When you construct a confidence interval for a mean, you are using the sample mean, and the symbol for that is x bar, to estimate the population mean, which is mu. I can't emphasize this strongly enough, that this is what you are doing when you construct a confidence interval. So in order to do this, the calculator will take the sample mean, again that's x bar, and it will create two numbers. It will create one number by adding the margin of error to the sample mean, and it will create another number by subtracting the margin of error from the sample mean. And that will give us an estimated range of values for the population mean, which again is mu. And that range of values is called an interval, which is why these are called confidence intervals. So what does a confidence interval for a mean look like? Remember, we said the calculator will take the sample mean, x bar, and add and subtract the margin of error to get an estimated range of values for the population mean, which is called mu. We can express this in a couple of different ways. We can say that mu equals x bar plus or minus e, or we can say it this way, which is the way you usually see it. This mu in the middle is between, that's what these two signs here mean when you have them on both sides of the mu. Mu is between x bar minus e and x bar plus e. So when we get a confidence interval, we're going to get a number here, and we're going to get a number here, and this is where each of those numbers comes from. That's how these numbers get constructed. X bar minus e, x bar plus e. And again, e is simply the symbol for margin of error. So now we're talking about sigma unknown. What does that mean? Well, I really hope that you have watched the video on constructing a confidence interval for a mean where sigma is known. If you've watched that, you'll be in pretty good shape on this, but I'm going to go through it in detail again. First, this is really important, so you have to get it straight. Every problem that asks you to construct a confidence interval for a mean will give you a standard deviation. It says read this statement again, so I'm going to read it again because it's so important. Every problem that asks you to construct a confidence interval for a mean will give you a standard deviation. That standard deviation will be either the standard deviation of the sample, and the symbol for that is a little s, or it'll be the standard deviation of the population. And the symbol for that is this Greek letter, which is called sigma. So when we say sigma is unknown, we mean that the problem does not give us the standard deviation of the population. Instead, it gives us the standard deviation of the sample. These kinds of problems, where sigma is unknown, these are the subject of this video. And as I've mentioned before, there is a separate video covering how to construct a confidence interval for a mean where sigma is known. How do I know which standard deviation the problem is giving me? Well, we're not going to go through it all again because it is covered extensively in the video called Confidence Interval for a Mean where sigma is known. So review that video and you will see a full presentation on how you read the problem and know which standard deviation the problem is giving you. So believe it or not, we're ready to do a couple of problems. Here's problem 1. In a test of the Atkins weight loss program, 40 individuals participated in a randomized trial with overweight adults. After 12 months, the mean weight loss was found to be 2.1 pounds with a standard deviation of 4.8 pounds. Another two questions here. They call them A and B. A, what is the best point estimate of the mean weight loss of all overweight adults who follow the Atkins program? And B, construct a 99% confidence interval estimate of the mean weight loss for all such subjects. And again, this problem is right out of the Triola text, page 355, exercise 20. So we're going to start with question A. This is easy. The best point estimate of the mean, and by the way, that means the best point estimate of the population mean. It just means a starting point for constructing our confidence interval. That is always simply the sample mean. In this case, the sample mean is 2.1 pounds. So that is the answer to question A. You could put in x bar equals 2.1 pounds, and that would be the answer to question A. The rest of this discussion addresses question B. So the first step is to understand the problem. Do you see the word test? Let's go back up and look at the problem and see where we see the word. There it is. I even highlighted it, okay? So we see that word test. That means that what is coming next is information about the sample. So the word test tells you that you're going to be getting information about the sample. Other words that mean sample: trial, survey, study, experiment, randomly selected. Anytime you see any of those words, it means you are getting information about the sample, and it's very important that you recognize that. See the words construct a 99% confidence interval estimate. Let's go back up and look at those words. There they are. I highlighted them. Construct a 99% confidence interval estimate. Those words tell us that this is a confidence interval problem. Do you see the word mean? Let's go back up and look. Here again, I've highlighted it. After 12 months, they're telling us here about the sample. They're telling us what happened to the mean weight loss in the sample. And then down here, where they tell us to construct the confidence interval estimate, they tell us that we are estimating the mean. So that means this is a mean problem. And that's important because we do mean problems differently from how we do proportion problems. Now, how does the problem describe the standard deviation? It says with a standard deviation of 4.8 pounds. And that is part of a sentence that tells you about the sample results. Let's go back up and look. Here it describes, in the first sentence, it talks about the Atkins weight loss program, and it says 40 individuals participated in a randomized trial. And by the way, there's another word, trial, that means sample, okay? So they're telling us about the sample here, and then they go on to give us more information about the sample. After 12 months, the mean weight loss was found. They're giving you information about the sample. So this mean here and this standard deviation, these are from the sample. So we saw that it was, oh, sorry, we're down here to the standard deviation. So it says with a standard deviation of 4.8 pounds. That's part of a sentence because it tells us about the sample results. That means that the standard deviation we're getting there is from the sample and not from the population. Also, we don't see any of the words or symbols that we usually see when we are being given the standard deviation of the population. If you don't know what these are, go back and look at the video on constructing a confidence interval for a mean when sigma is known. So again, big picture here, we're not getting the population standard deviation, we're getting the sample standard deviation. That means sigma is unknown, and that means we're going to be using t-interval. We'll get to that in a minute. The next step is to write down the sample statistics. The problem says 40 individuals participated in a randomized trial with overweight adults, and they continue, and all of this stuff is telling us about the sample. So this is where we're going to get our information about the sample. This is where we're going to get our sample statistics. For a mean problem, the sample statistics that we need are n and x bar. N is the sample size, how many are in the sample. X bar is the mean of the sample. We also need either the sample standard deviation, which is S, or the population standard deviation, which is sigma. Well, we've already figured out that this problem does not give us sigma, but it does give us S. So n is the number of subjects in the sample. In this case, that is 40. So our first sample statistic is n equals 40. The sample mean is given as 2.1, and that dollar sign does not belong there. So that's the sample mean. So x bar equals 2.1. That's our next sample statistic. And the last, the sample standard deviation is given as 4.8. So we say S equals 4.8. So there are the sample statistics we need for this problem. N equals 40, x bar equals 2.1, and S equals 4.8. Now we're going to use the calculator to construct our confidence interval. You're going to see how ridiculously easy this is. The first step, go to Stat Tests t-interval. Notice in red here, we use t when sigma is unknown. Very important. So our whole purpose in finding out whether we know sigma or not is to know what interval we're going to use. And when sigma is unknown, we use t-interval. If you looked at the video when sigma was known, we used z-interval. And we'll see both of these on here when we go find t-interval. So we're going to do just what it says here. We're going to go to Stat. We're going to scroll over to Tests. And then we're going to scroll down. So you see here number 7 says z-interval. That's what you would use if sigma was known. But we have to keep going. And there's t-interval. And that's what we're going to use now, because sigma is unknown. So I'm going to hit enter. And here's our screen. Input, data or stats. Well, this information we were given is sample statistics. It would be data if we had put numbers into a list, but we didn't. It gave us the sample statistics. So we're choosing stats right there. X bar equals 2.1. So I'm going to come down to X bar, and I'm just going to type in 2.1. Sx equals 4.8, so I'm going to arrow down to Sx, and I'm going to put in 4.8. N equals 40. Well, that 40 we already have there, so that's going to work. C level, that means confidence level equals 0.99. So I'm going to scroll down. This one is 0.95. Well, that doesn't work. We need 0.99. So 0.99. Then we go down to calculate. We hit enter. And it's thinking, and there is our confidence interval right there. That is the answer to the confidence interval question. And I've just printed that out right here. The calculator answer is this. So to answer this in words, we would say we are 99% confident, and that 99 comes from that right there. We are 99% confident that the true population mean of the weight loss for all overweight subjects on the Atkins weight loss program is between 0.04484 pounds and 4.1552 pounds. So that will generally be a sufficient answer to this question, but let's delve into it a little bit deeper. So here we're going to work a little bit to understand this confidence interval. You've got these two numbers here, but they may be completely meaningless to you. You may have no idea where those numbers came from. Well, we're going to find out right now. And we're going to start with what I call the structure of the confidence interval for a mean. And we talked about this a minute ago. What we're saying is that mu is between x bar minus e and x bar plus e. So we know x bar. That's simply the sample mean that was given to us in the problem. So for this next step, I'm going to put that sample mean right in there. 2.1, that goes in place of this x bar. 2.1 goes in place of that x bar. Now we need e. How do we get to our margin of error? Well, what we're going to do right now is to do it the easy way, or the shortcut way. And the shortcut way to calculate e, and here you see this formula, is to take the high end of the confidence interval. In that case, this is 4.1552. Subtract the low end of the confidence interval, 0.04484. So that's what's going on here. And divide that result by 2. So when we do that, when we subtract, we get 4.11036. We divide by 2, and we get 2.0552. So that is the margin of error. And again, the symbol for margin of error is E. Well, now that we have the margin of error, we can drop that in place of E. So now if we go back to this thing, there's our 2.1. Now we're subtracting the margin of error, 2.0552. Here we have the 2.1, and we're adding the margin of error, 2.0552. And if you add these together, you will get this number, which is the high end of the interval that the calculator gave us. And if you subtract, you will get this, which is the low end of the interval that the calculator gave us. So those are the pieces to where these numbers come from. So now we're going to look at how we would calculate the margin of error if for whatever reason we were not able to do the shortcut. If there's an assignment that requires us to use the formula, we'll see how to do it. So it says above we see the shortcut way to find the margin of error. We know what that is. But there is a formula, and that's how the calculator constructs the confidence interval. It uses the formula for E, and it calculates E, and then it does the rest that it needs to do to create the confidence interval. So here is the formula for E. E equals T alpha over 2 times S over the square root of n. T alpha over 2 is called a critical value. And the only tricky part of using this formula is finding the critical value. So in this problem, the margin of error works out like this. S and the square root of n are easy because both of those are given to us in the problem. The problem gives us S, which is 4.8, and the problem gives us n, which is 40. So that part is easy. The only tricky part is finding the T critical value. And again, T alpha over 2 is called a T critical value. So to find the T critical value on the calculator, first of all, let me mention, we're going to use a calculator function here that's called inverse T. Most of you should have this on your calculator, but those of you who use a TI-83 calculator, you probably don't have this on your calculator. If you come see me, I can put a program into your calculator that will do the same thing that this built-in function does. But for the moment, I'm going to assume that this is going to apply to people who have this on their calculator. So in order to find a T critical value, alpha over 2, the first thing you need to know about is alpha. What is alpha? It's a Greek letter that looks like this, and there you see it. I put it in red. That's the Greek letter alpha. How do we compute alpha? It's very simple. Alpha equals 1 minus the confidence level. In this problem, the confidence level is 0.99, so alpha equals 1 minus 0.99, which is 0.01. So for starters, alpha equals 0.01. The calculator function we're going to use is second vars invt, and then this is what we're going to put into that function, is alpha divided by 2 and something called df, or degrees of freedom. So let's look at those one at a time. Alpha divided by 2. Well, we know that alpha equals 0.01. We calculated it up here. So alpha divided by 2 is 0.01 divided by 2, which is 0.005. So that's what's going to go into this part of the calculator function. df, that thing right here, that means degrees of freedom. And the formula for df is n minus 1. In this case, n equals 40. So the degrees of freedom is 40 minus 1, which is 39. So df equals 39. So when we go to the calculator, we're going to do second vars INVT 0.01, which is, 0.01 divided by 2. So that's alpha equals 1 minus the confidence level. That's the 0.01. We divide it by 2. And the degrees of freedom is going to be 39. So let's go ahead and do this on the calculator right now. Second vars, there you see INVT. So INVT, and we're going to put in 0.01 divided by 2 and 39. So 0.01 divided by 2. Then we need to put in a comma, and then we're going to put in 39. And I'm going to hit enter. And there you see our answer, negative 2.7079, etc. So I rounded that to negative 2.708. For the critical value, we drop the negative sign. So this critical value, T alpha over 2, equals 2.708. And just to remind you, that's what we put in right there, was 2.708. I have to make sure you know, this is a very superficial treatment of how to find a T critical value. To really understand it, we should draw a picture of a T distribution. But I hope to do another video that will go into greater depth on finding critical values for all confidence intervals, how you do it, and what you're really doing when you find a T critical value. Let's try another problem. Movie lengths listed below are 12 movie lengths. Listed below are 12 lengths in minutes of randomly selected movies. Construct a 99% confidence interval estimate of the mean length of all movies. And here you see, this movie was 110 minutes long. We don't know what movie it was, but that's how long it was. This movie was 96 minutes long. This movie was 125 minutes long, and so on. They do that for 12 movies. They tell us how long each one was in minutes. And this problem comes, again, right from the Triola text, page 356, exercise number 28. So the first step is to understand the problem. Do you see the words randomly selected? See, they're right here, randomly selected. That means that what is coming next is information about the sample. However, in this case, the sample information is different from the sample information in the last problem. The last problem gave you sample statistics, if you remember, n, x bar, and s. This problem doesn't do that. Instead, it gives us the actual data. That's right here, these 12 numbers. So that data, that is the running times of the movies. So because of that, there will be a slight difference in how we solve this problem on the calculator. See the words construct a 99% confidence interval estimate. There you go, I've highlighted them. That tells us that this is a confidence interval problem. Very important words. You see the word mean? There it is. I highlighted mean. That tells us that this is a mean problem and not, for example, a proportion problem. If it were a proportion problem, we would solve it slightly differently. See if the problem gives us the population standard deviation. It does not. In fact, it doesn't give us any standard deviation. But hopefully we recognize that since we have the actual data, which again, that's all those numbers right there, since we have the actual data from the sample, we could easily find the sample standard deviation. For most problems, the next step is to write down the sample statistics, n, x bar, and s. But in this case, we don't have to, and that's because we have the actual sample data. So instead, we need to enter the data into a list on our calculator. So on the calculator, we will hit Stats, Enter, and then simply type all the numbers into a list. So I'm going to do that right now. I'm going to go up here. So there's our numbers. So I'm going to hit Stat, Enter. I'm going to go into list 1. Well, the first thing I'm going to do is I'm going to clear out what's already in list 1. So I'm going to hit Clear, Enter. And then I'm going to type all these numbers into the list. So there's the 110, 96. And I'm going to pause this recording for a minute while I fill in the rest of the numbers. Okay, I have finished entering all the numbers in the list. And now it says use the calculator to construct the confidence interval. So we're going to go to Stat, Tests, T-interval. Stat, Tests. Again, I'm going down. I'm looking for T-interval. Notice I did not stop at T-test. That's something different. So I'm going down, and I'm also not stopping at Z-interval. Just as a reminder, I would use Z-interval if we knew sigma, but we don't know sigma. So we're going to use T, and there it is, T-interval. So I'm going to choose that. But now, the first thing I have to decide, am I inputting data or stats? Well, now I did not input any stats. I simply inputted my data into list 1. So we need to choose data here. So I'm going to arrow over to data. And then I have to hit enter so the cursor stays on data. And then you'll notice these selections change when I go from stats to data. So the first one says list. My numbers are in list 1. You could put them in any list you want, but I put mine in list 1. So we're going to stay with list 1. The frequency is always 1. In this case, the confidence level is 0.99, so that's good just like it sits. And we're going to go down to calculate and hit enter. And here is our confidence interval right there. That is the answer to the question, and I've typed it out here. 103.5 is the low end of the confidence interval. 140 is the high end of the confidence interval. Notice the problem didn't ask us for this, but the calculator gave us our sample statistics. N equals, you see they're all right here, X bar, S, and N. N equals 12, X bar equals 121.75, and S equals 20.36. If we need to state our solution in words, we would say, we are 99% confident that the true population mean length of all movies is between 103.5 minutes and 140 minutes. Again, let's understand what goes into these two numbers. Where did they come from? They're not just out there in the cosmos. They're there for a reason. They got computed, and we're going to see how that happens. The structure of a confidence interval is mu. The population mean is between X bar minus E, that's the little number, X bar plus E, that's the big number. So I'm going to start putting in what I know. X bar, in this case the calculator told me X bar. I could have calculated it separately, but the calculator told me that X bar is 121.75. So that goes in place of this X bar, and that number, same number, goes in place of this X bar. Now the shortcut to calculate E, see E and E, the margin of error, the shortcut for that is to take the high end of the confidence interval, there's your 140, subtract the low end of the confidence interval, that's 103.5, that's that right there, and then divide that result by 2. So if you take 140 minus 103.5, that's 36.5. You divide by 2, you get 18.25. So that is E, the margin of error. So now I want to drop that number in for both of these two E's. So that brings us down here. 121.75, again, that's just X bar. By the way, I forgot to mention, if you have a problem asking you for the best point estimate in a mean problem, it's simply X bar. It's simply X bar. So going back down here, we have X bar 121.75 minus E, which now we know is 18.25. Here we have X bar plus E, 121.75 plus 18.25. You add these two together, you get 140. You subtract these, you get 103.5. And those are the two numbers in our confidence interval. So let's talk about the academic way to find the margin of error, which you may have to do sometimes. Above, we saw the shortcut way to find the margin of error, but now let's take a look at the formula. So in this case, where we do not know sigma, the formula for the margin of error is this T alpha over 2. T is the critical value. T alpha over 2 is the critical value. And by the way, the reason this is T is because we don't know sigma, so we use a T distribution. When we know sigma, this is a Z right here. And then the rest of the formula is S divided by the square root of n. The calculator gives us S, the calculator gives us n. So those are the easy parts. The tricky part is always finding the critical value. So if we come down here, S was 20.36, the calculator told us that. N was simply how many movies we had the lengths of. That was our sample size, that's 12. The critical value, that we have to find. So now we're going to talk about how to find the critical value. Finding a T critical value, in this case T alpha over 2 on the calculator. And we've already covered some of this before, but I'll go through it again. We need to know about alpha. This is a Greek letter that looks like this. This is what alpha looks like. How do we compute alpha? It's 1 minus the confidence level. In this problem, the confidence level is 0.99, so alpha equals 1 minus 0.99, which is 0.01. So alpha equals 0.01. The calculator function, and we'll do this in a second vars inverse t, and into that we put in alpha divided by 2 and degrees of freedom. I'll mention here what I mentioned before. The TI-83 calculator may not have this function. If you don't have this function, come see me, and I will give you a calculator program that does everything we're talking about here. So alpha equals 0.01, and again, what I'm doing here is we need to figure out what is alpha over 2, and we need to figure out what the degrees of freedom are. That's df. So we know that alpha is 0.01. We found that up here. So alpha divided by 2 is simply 0.01 divided by 2, which is 0.005. Again, df means degrees of freedom. That's n minus 1. In this case, n was 12. So the degrees of freedom is 12 minus 1, which is 11. So our degrees of freedom equals 11, and I should have colored that whole thing. Okay, so we're going to go to the calculator now. So let's do that. On the calculator, we hit second vars inverse t. So second vars, there's inverse t, which is number 4. And we're going to put in 0.01 divided by 2. That's the alpha divided by 2. And again, alpha equals 1 minus the confidence level. That's where the 0.01 comes from. So 0.01 divided by 2, comma, degrees of freedom is 11. We close our parentheses. We hit enter. And it's thinking, and there's our answer, negative 3.1058. And that's what I put right there. For the critical value, we drop the negative sign, so the critical value, T alpha over 2, is 3.1058. So that is the number that went in right there for the critical value into this formula to calculate E. I want to emphasize, this is a very superficial treatment of how to find a T critical value. I hope to do another video that will go into greater depth on finding critical values for all confidence intervals. And that is the end of this video.